Hi guys, so we're going to talk about rational functions and their asymptotes. Okay, so here we go. We're going to start off with the vertical asymptote. Okay, and what a vertical asymptote is you set the denominator equal to 0 and solve for x. Okay, so let's do an example. So let's say, y equals 3x minus 1 over x plus 2. So what we would do is for our vertical asymptote is take the x plus 2 and set it equal to 0 and solve. By the way, vertical asymptote, kind of forgot. I shorthand it as VA. Okay. And then solve for x down here. So we're going to subtract 2 from both sides, and we get x equals negative 2. And that is it. Okay. Now, horizontal asymptotes. There's 3 things we have to look for. Horizontal asymptote. And I'm going to call this HA. So the first one. If the degree is larger on top then no horizontal asymptote. Okay, so let me do an example here. So let's say 3x to the 4th minus 5x squared plus 2 over 6x squared plus 1. Okay, I'm trying to find a pen, sorry. So your degrees have to deal with the largest exponents. Okay, so this is my degree. My top degree is 4, the bottom is 2. So since the degree here is bigger on top, no horizontal asymptote. Okay. Next, sorry about that. So if the degree is larger on bottom, then the horizontal asymptote is y equals 0. Okay, so if we take the same problem that we just did, and I'm just going to flip 3x to the 4th. Okay, so again, the degree on top is a 2, the degree on bottom is a 4. Since the degree on the bottom is a 4, it means a horizontal asymptote is just y equals 0. Okay, not too shabby, right? Okay, and then if degree is same on top and bottom, then divide by leading coefficients. Okay, and I'll give an example of that. Let me just turn my page. Okay, so if I turn my page, let's do an example. So let's do, I don't know, 5x to the 4th plus 2x squared minus 1 over 2x to the 4th plus x cubed plus 5. Okay, so my degrees are the same, the fourth. So the leading coefficient is going to be the number in front of that term. So since this is x to the fourth, the top here, so my horizontal asymptote, the top coefficient is a 5, and then on the bottom it's a 2. Okay. I hope that makes sense. Okay. Now, last problem. Or last type of asymptote. It's called a hole. And a hole is if you have the same factor on top and bottom, then set the denominator equal to 0 and solve for x. Okay, so here is an example. So let's do x squared minus x minus 2 over x squared minus 1. Okay, so first step is always going to look and factor if possible. So the way we're going to do this is you ask yourself, what two numbers multiply give me 2? That subtracts and gives me -1. Okay, and there's only one number that gives us 2, which is 2 and 1. If I subtract it here, I get a 1. I need a -1. So we're going to flip this. And we get that. Okay, let me get that away from you. Okay, so that'll be x plus 1 and x minus 2. Now, if you don't like x squared, and I'm going to kind of do this over here. If you don't like x squared minus 1, and you like it better with 3 terms, we can rewrite this as x squared plus 0x minus 1. It doesn't matter. This is the difference of two perfect squares. This says the same thing, I just put in that middle term. And you do the same thing. What two numbers that can I multiply to give me 1? When I subtract, I get 0. And that will be x plus 1 and x minus 1. Okay. So here we go. Let me grab a different color pen. So do you see right here we have x plus 1 on top and on bottom. So that means we have a hole at x plus 1. And we're going to set that equal to 0. Subtract 1. And we get x equals -1. Okay, now vertical asymptote. Oh, and I forgot to do a little side note. Side note, I'll just say it. You cannot be a hole and a vertical asymptote. You either one or the other. So you see how x plus 1 is a hole? So that means x minus 1 becomes my vertical asymptote, because I've already used this one already. So add 1, so we get x equals 1. Okay, so now let's deal with our horizontal asymptote. I'm going to slide back up here. So my degree on top is a 2. On bottom, it's also a 2. So my leading coefficients in both cases are 1. So that would be y equals 1 over 1. Or just plain old y equals 1. Okay, I hope this helps. I'm going to make another video of a couple of extra problems to try. I wish you luck.